So this video is on classwork 8-33 to 37 when we're learning how to find the area of various polygons. I am going to go through question A and B on 33 with us, where we have a square, which actually is dealing with a 45, 45, 90 right triangle, and question B, a hexagon, a regular hexagon, which is actually going to end up giving us a 30, 60, 90. Then I'm going to go through 35A. I will work that one out. And then I'm going to leave it to you to, I'm going to do one like B, but not exactly B, and like C. Okay. Now, the difference between these, on question A, you are given the radius where it's coming from the center of the polygon to a vertex. That is the radius. When you have it coming from the center to the side, the midpoint of the side, this is the apothem. Okay, this is going to be when I draw my triangles, my height of my triangle, where this would be one of the sides of my triangle, of my isosceles triangles. Okay. And then this one you have the side, which would be like the base of my triangle when I split these into triangles. Okay, so that's what we're going to do. So let me start. Okay, so on this first one, on the square. So for this, okay, I know that this is 6. I also know that this is going to be 6 because this is going to be isosceles because it's coming from the center of a regular polygon. Now, in terms of figuring out this middle angle, I know that if I go all the way around these central angles, it has to add to 360 degrees. So I am going to take 360 degrees, which is all the way around, and divide it by how many equal angles I have here, which are 4. And so that's going to be 90 degrees. So this ends up being, let me get rid of this. This ends up being 90. So this is 90. So that is nice because when I'm trying to find the area of a triangle, I need to know my base and height, which have to be perpendicular. So these are going to be my base and heights. And if I turn it around something like this, you can see, okay, there's your base, there's your height. They always have to be perpendicular. Okay. Now, I don't need to find the side, but I'm just going to talk about the side right now in case I had to for something else. Since this is a 90, this is isosceles, that means that this is 45 and this is 45. So I have a 45, 45, 90. So if these across from my 45s are 6, then the one, my hypotenuse is going to be 6 root 3. Again, I didn't need that. I would if they asked me for perimeter, okay, but I don't need it for my area. So now I'm going to find the area, and the area I want to find is the area of this triangle right here. And I have 4 of them. Okay, so again, when I'm trying to find that area, the formula I'm going to be using is base times height divided by 2. Okay, so I am going to take area of triangle equals base times height divided by 2. So that is going to be 6 times 6 divided by 2, which is going to give me 36 divided by 2 is 18. So now I know that each of these is 18, 18, 18, 18. So when I'm trying to find the area of the square is going to equal 4 times 18. And 4 times 18 is 72. And so that's going to be 72 square units. Now on the next one, letter B, I have a regular hexagon, okay? So I'm going to do the same setup where I'm going to start at the center and I'm going to draw out. And when I draw out, I am going to get 6 of these, okay? Okay, 6 triangles. Now, again, when I'm trying to think about this and I'm going all the way around, I am going to be taking 360 divided by 6, which is 60 degrees. So each of these angles is 60 degrees. Okay. So this is going to be 60 each of these. Now, this is also, since these are both radii, these are going to be the same. So again, it's always isosceles. Now, if this is 60 and this is isosceles, that means these two angles have to be the same. And so 180 minus 60 is 120. So this actually ends up being, and I'm going to write in a different color so you don't think I got it from there. This is going to be a 60 and a 60. So I actually get an equilateral triangle here. Okay, that is not always the case. So since this is 8, then this is 8, and this is 8. Okay, so now what I'm going to do is I'm going to take my equilateral triangle. Okay, and here I'm going to draw it a little bigger. And here, why don't I just even use their triangle shape? That'll be better than my triangle shape. Okay. Okay, and so here's my triangle shape. So what I have here is, again, this was 60, but I'm going to split that 60 in half, which makes this a 30 and a 30. And again, here is my 60, here is my 60. So I have a 30, 60, 90 right triangle. Okay, again, it was equilateral. It's equilateral when I have a regular hexagon because I have 6 equal angles, and 360 divided by 6 is 60. That gives me a 60 here, which means because this is isosceles, the 120 which is left over splits into another 60 and 60. That's not the case with other shapes that are not hexagons. They will be isosceles but not equilateral. Okay, so now I know that this is 8. I know that this is 8. I know that it's 8 going across, so that means that this is a 4 and that is a 4. So now I know that my base is 8. I need to figure out this height. But since this is a 30, 60, 90, I can do that nicely. Across from my 30 is kind of that building block, 4. I double that 4 and I get 8. Okay, my hypotenuse. I take that same building block and I times it by √3, and that's going to be this height here. So now I really have, if I want to find the area of this triangle, so area of triangle is going to equal my base, which is 8, times my height, which is 4√3, divided by 2. So that is going to give me 16√3 when I do that math. And so each of these is 16√3, and I have 6 of them. So the area of, and I'm going to put P for polygon. Okay, it's a hexagon in this case, but P for polygon. I have 6 times 16√3. And when I do 6 times 16√3, I get 96√3. And that's your answer. Okay, 96√3 is your answer. I'll do it in a different color so we can see. That is your answer. Okay, both of these were special ones. One ended up being a 45, 45, 90 when you have a square. A hexagon, we end up with a equilateral triangle instead of just an isosceles. And we end up with a 30, 60, 90. Okay, so I'm going to go over the next one. So for this one, let's first count the sides. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it's a nonagon. I've got 9 sides. Okay, so let me just make sure. It helps if you know how many sides you have first. Okay, so we have 9 sides, which means I'm going to have 9 triangles when I set this up. Okay, and here, let me just get rid of all of those markings. Okay. And so now when I draw my triangle, again, as I'm going around the whole thing, I'm going to have 9 of these. I'm not going to draw all 9 of them. I know that that means I'm going to take 360, which is all of my central angles together, all 9 of them. I'm going to divide it by 9, and I end up getting, for this, 40 degrees. Okay, 40 degrees. So that means that this is going to be a 40 degrees. I'm just going to zoom in so I can write that 40 here. That is going to be a 40 in that central angle. Now I could find these angles. I don't need to. I don't care about that. What I need is I'm going to need this side and I'm going to need this height. And so I know I have an isosceles triangle here. Okay, I'm going to split this isosceles triangle in half. So that's what I'm going to do over here. Okay, so I am going to take this. I'm going to draw, and hold on, let me get that. So I was doing this on my tablet. I just switched over to the computer. Here, hold on. Actually, I did not switch the screen. Let me switch over to my computer screen. Sorry. Okay. Just to show you that if you were doing this on your computer, I come here to the shapes, I can make right triangles. And we've done this before, but just a little reminder. If you hold the shift while you're doing it, okay, then whoops, I'm doing a circle. That's going to make a circle. Okay, so it helps if I actually got a triangle. Okay, and let's see, I have this really fat right now. Let me change it, and I'll change it back to purple. Okay, so let me start here. So if I take this and I hit shift, then I can make my right triangle. And I'm not really concerned with the actual angle values here, okay? I just want to get a triangle. I could do it to get it to be a 20 if I wanted at the top, but that's okay. So now I've got my right triangle that I can use, okay? Just a little option for you. Okay, so back to my tablet here. Okay, so this is going to be 20. Okay, I don't really care what this is. It's going to be 70, but I don't really care. That's not what I'm concerned with. I'm just going to use that 20. I've got that 20. I'm just going to use that 20. And I know that this is 11. Now, unfortunately, in this case, I don't know my base or my height. So I'm going to use some trig. I'm going to call this X, and I'm going to call this Y. Okay, so to find X, what I'm going to do is if I'm here at this 20, this is opposite, this is hypotenuse, I'm going to use sine. So I'm going to do sine of 20 equals x over 11, which means when I try to get x by itself, I get 11 sine 20 equals x. Okay, and that's what this value is. Okay. And so I'm going to put that. Okay, so let's see. So I'm going to put 11 sine 20 here. And I'm going to do the same idea for my y. So this is going to be adjacent over hypotenuse. So that's going to be cosine. So I'm going to do cosine of 20 equals y over 11. So that's going to be 11 cosine 20 is equal to y. Okay, so I'm going to put that over here. And so this is going to be 11 cosine of 20. So now remember, I'm not finding the area of this half of a triangle. I'm finding the area of this triangle over here. Okay. Of this triangle right here. This is the triangle I'm trying to find the area of. This is half of that. Okay, so just remember that when we're doing this. So when I'm trying to find that area, I am going to take for a triangle base times height. Now the base is this whole thing. So if I'm doing this whole entire thing, this was 11 sine 20. This is going to be double that. So I'm going to double it. It's going to be 22 sine 20. And then I know my height was 11 cosine 20. So I am going to move this over or shrink it down slightly so we can see this. So I am going to do area of triangle equals 22 sine 20 times 11 cosine 20 divided by 2. Okay, now I really could divide this by 2 and get an 11 here. So this is going to be really 11 and 11, which is 121 sine 20 cosine 20. Let me just move this. Okay, sine 20 cosine 20. And that's going to be the area of the triangle. Now I had 9 of these, so area of my polygon is going to be 9 times this. And I actually can cut and paste this. Let me show you. I can do it better on my computer. So if you come to select up here and select annotation, okay, now sometimes it might do more than you want. Okay, that's what I want. I can actually copy and paste. And so now I can just move that, and I didn't really want the equal part, but that's okay. I can get rid of that here in a second. Okay, and then I can just work that out. Oh, sorry, you weren't seeing that. So let me reshare. Okay, and I will undo what I just did. Okay, so let me get rid of this. Okay, so hold on, I'll just get rid of this. So what I had done was I came up here to this select annotation, and then I can come across. Let's see, can I get it so I don't get that? Hold on. If I start over here, I might have to get that equal. But what I can do is I can copy and I can paste, okay? And so I can paste that in here. So let me get, I'm actually going to erase just my equal right now. Okay, and then I'm going to move this whole thing here. And there you go. Just a little trick. Not any math importance, but just showing you. Okay. Okay, and then I'm going to take this and put this in my calculator. So I'm going to go 9 times 121 sine 20, making sure my calculator's in degrees. Close out parenthesis. I'm going to put a times in between. I probably don't need to, but I'm just going to be safe. Cosine 20. And I end up with 349 point. Well, it's actually going to round up to about 350, isn't it? Because of the 997. So here, I'm going to round it up to about 350 as my answer. Okay. And now I'm going to do one like B, like C, but again, slightly different. So this one that I drew is going to be like C. This is not C, okay? This one is a pentagon, but what it has is the apothem from the center down where it's perpendicular, and we need to figure this out, okay? So let me just make this a little bigger here. So again, we are going to want to make this into a triangle, okay? And I have 5 sides. So I'm going to be taking 360 divided by 5, which ends up being 72. So each of these is 72. Okay, so it's 72 going across. So from here to here is 72. Okay, here, let me draw that a little nicer without as much stuff in it. Okay. So again, when I'm drawing this, this is going to be 72. Okay. Now the part I knew, let me get rid of this part so we just kind of see this one more time. The part I knew was the apothem, which was from my center down, and I was saying that that was 10. Okay. So I know the height of this is 10. I need to find the base of it. Okay, so I'm going to take this triangle and I am going to draw it, and I'll do it right here, in half. So again, this was a 72, now it's a 36, and this was 10 that gave me this. All I need to find is this. So I'll call this X. So this is going to be opposite over adjacent. So I'm going to be doing tan of 36 is equal to opposite over adjacent. So 10 tan of 36 is equal to X. So this is tan of 36. which means all the way across is going to be double that, which is 20 tan of 36. So now when I'm trying to find the area of this, and here, let me write it here so you can see it in this picture. So this is 20 tan 36. I am going to take the base times the height. And remember, the height was 10. Okay, so I'm going to take the base times the height. So let me shrink this out a little bit. Okay, so I'm just going to redraw this. So we know that this is 10. We know that this is 20 tan 36. And so if I find the area of this, the area of that is going to be my base times my height. So that's going to be 2 tan of 36 is the area, times my height. Wow, I'm rushing. Times my height, which is 10 divided by 2. So that's going to be a 10. This is going to be a 100 tan. Okay. 100. So again, my base times my height, all divided by 2. So half of 20 is 10. 10 times 10 is 100. So this is the area of this triangle is 136. I have 5 of them. Okay, so my total area, okay, of the actual shape is going to be 5 times that, which is 500 tan of 36. And put that in my calculator. 500 tan 36, so you can see it, is equal to about 363.27. And that's going to be our answer. Okay. Okay, now on this one, this has 7 sides. Okay, so this is like letter C where we have like this number here. And so in this case, what I need to do here, I'm going to do it in a different color here. I am going to, again, get an isosceles triangle. We always do from our center. I have the base this time. This time I need to find this height. That's what I need to find. And since I said we have 7 of these, I'm going to take 360 divided by 7. Okay. 360 divided by 7, not going to be the nicest number here. And I get, let's say, about a 51.43. Okay. So about a 51.43. That's what I'm going to be getting here. Okay. Now I'm going to be taking half of this when I'm doing the triangle. Okay. And I know that this would then be 5. And I'm going to be taking half of this. So I'm going to divide this in half, which is about a 25.71. So this is a 25.71. Okay, 25.71. Let me make it a little bigger. So now what I'm going to do is I'm going to find the area of this, but I need to find the height. So to find the height, let's call this y. I know opposite. I need to find adjacent. So I'm going to do tan of 25.71 equals 5 over y. Now, if I don't want to have my y on bottom, I can instead use this angle here. Okay, and so that would be 90 minus that. And so that would be a 64.27, okay, is what you could be using here instead if you prefer. Okay, so I'm going to cross multiply. I get y tan of 25.71 equals 5. I get y equals 5 over tan 25.7. That's going to be this value here. That's going to be my height. Okay, so now I'm going to take my base. Now remember, my base is really all 10. So area of triangle. My base is 10. My height is this. I'm just going to rewrite it here. I'm going to put it all in my calculator. Okay, 25.7. That's going to be divided by 2. That's going to be the area. So really, when I divide this by 2, this is going to become a 5. Okay, or I can just put it all in my calculator, up to you. So this is going to be 25 over tan 25.7. That is going to be the area of one of these triangles, okay? And I have 7 of them, okay? So for the total area, okay, so again, that's the area of the triangle. For the total area, I am going to take 7 times this. Oops, I forgot my tan. Okay, there we go. 10, 25.7. Put that into my calculator and let's see what we get. Okay, so I'm going to go 7 times, I'm going to do alpha y equal to get my fraction. Okay, and then I'm going to put in 25 over tan of 25.71 or 7 here, 7. And I end up getting about a 363.63 as my answer. Okay, so hopefully this is helpful. Just trying to show you when you have just the base or the side, one where you had the apothem, which is from the center down, and the one that was on the worksheet where you had a radius. Have a nice weekend.